Yeah, it's basically a simulation of the evolution.
Yes. So you have a certain pool of initial decisions. Some have a certain positive effect of your objective function, some don't. The one that approximate better the positive effect might cross with each other, or you can have some mutation, some strategies just change, and this basically determines the process of the strategy. So you have an initial population, you have an ideal case or a fitness test, you select the best parameters, you breed them, you have children, you can mutate them, and then you restart the process again. So you can start with you have the choice between thousands of different types of strategies, and you end up with two that might work under different scenarios. Okay, depending on obviously on your objective function. And that's very important. Your fitness function is what actually drives each type of decision at the end of the day. That is at least my opinion. If you have a different one, you're very welcome to share it. No? Another way to try to model these types of these decision making is to use rule-based algorithms. These where agent-based models are very nice and they're very easy to use for these type of models. Because you behave according to certain conditions, so you have basically if-then rules, and you can have conditional conditions. Sorry for the word. So if A happens and B happens, then I behave C. But if A or B happens, then I behave D. So and you have a probability. You also have probabilities of behavior based on the inputs that the environment is giving to you and the input that the environment is giving to you. Okay? And this is another way we can model these decisions, and you can actually model the interactions between human and environment. Because one fundamental thing is feedbacks. Feedbacks are fundamental. Well, they are fundamental in the natural world, but they are also fundamental in the human world, and the interactions between human and environment is based on feedbacks. Now we can talk about learning feedbacks, so I make a decision, I see if it works or not, I try to correct it, so the next time steps, I correct my decision and see what effect it has on the environment. And that is a learning by doing in a certain way, or adaptive management. I think now that is what is used most of the times, but there is not much difference between the two. And obviously also we have positive and negative feedback, so you can have different meanings to word feedback, depending on the context you're in. And these two are actually fundamental when we really want to couple human and natural systems. Yes?
So in a setup like that, when you've got these 8-10 types of rules, you don't really prescribe the weights of the individual rules, right? You let the network learn.
Yes.
How to do it.
You let them learn, so you start with a certain amount of possibilities. You normally give them, you obviously can't give them infinity, no? Because you already know more or less, hopefully, because the literature gives you an idea, or your empirical test gives, or your case studies gives you an idea of what are the possible decisions in that spectrum, and then you try to make them learn. It's very similar to what you're doing on neural networks, but I'm not going into neural networks because it takes So the problem is that these things are very good if we are alone, but we are not alone. And we actually decide in groups. So when we are in the group, okay, we can learn by ourselves a lot, but being in the group can actually be a very nice shortcut, or can actually hinder a good decision. I do believe the interaction between individuals are structured, so we can't assume homogeneous mixing when we take these things into account. And I believe that decisions are often, and these structures influence imitation and innovation. Okay? And I also believe that a lot of times decisions are driven by authority, cultural views, and individual personal characteristics. There's a very branch of physics called sociophysics that deals with opinion dynamics and opinion diffusion. And there are very simple model by a guy called F1. And he actually very simply says that if we have a very different personal view of the world, our opinions will almost never converge. Unless you have a huge authority on you. And then we are forced to converge. And I remind you that authority is the power or the ability, to make other people do what you want them to do, either by legal means or because you have a good reputation or a high reputation. Do you think there are other things that might come into play? I took away the economics. But well, it's very important. Cost, risk are very important. But I think that unfortunately, a lot of times this is how actual decisions are made. Is a gut feeling, or is the common sense, or the neighbor that you're talking to. A lot of decisions are actually. Some people told me a story that women in parliament have a lot of problems in certain countries because a lot of decisions are not actually taken in the parliament, but in the restrooms. And obviously men goes in the same restroom and the woman can't enter that. No? So, and again, what influences decisions, networks, authority, personal views. This is my opinion. If you have another one, you're very welcome to share it. Yes?
I think there are some other factors as well, because authority, I would put it under authority, it's not only authority, it's someone can be, let's say, with less authority, but he speaks very well, he or she speaks very well, or knows how to present their ideas very well, and they immediately get the attention. In addition, there are also political values here, that there is the known saying, you stand where you sit.
Yes, you're perfectly right. And that's why I lump them all together to make the model as simple as possible. And all you say about I speak well, and so I get your attention, is a way of reputation. So in a certain way you can lump it, you say it's under authority. No? You can somehow put it in a parameter if you have a parameter. And it's the same thing that where you sit is your own personal view. So that also can be. And this is, I think, the minimum amount of complexity you can have.
What about tradition?
Yes, it's personal views. Obviously, I know that if you talk to anthropologists about these, you will have a lot of problems in trying to convince them.
And what about accidents? Some decision was made by accident, but not.
Yes, that's the randomness. Randomness is hard to. Yeah, unfortunately, I guess some decisions are made by accident.
Mutations. Decision mutations.
Decision mutations. Yeah, you can.
I think you can lump all that into alcohol.
Yes. Alcohol? Yeah, that's actually, that works very well. Yes?
What about like the simple majority? If we think about the climate models, then we always take the mean, or the thing that we think in majority is right?
It's like, that comes if we extend it, we have rules on the interaction, so on the networks, a lot of models about cascade effects are made on majority rules. So if I have more than n neighbors that like the game of life, for example, or Holland experiments with one light bulb and all the other connected to it. So the light bulb is on if at least 3 of his connections are on, and is off if his neighbors are off. And it creates a lot of complex patterns. Often they are unpredictable. But so yes, that's very important as well. So how the connection work is fundamental. Yeah. The emotion, that's very hard to. That's why. But the fact is that I do think these emotions and cognitive processes are very important. But at the end of the day, what is important is what do you observe, a yes or a no, in most cases. Yeah. Here, for example, it says all those in favor say yes, and everybody says yes, but everybody is thinking no way. But they have to do it. So these will be the emotion and the cognitive process that goes on, and this is actually the outcome. So this decision will be made, even in a political setting. And so we are very interested, actually, I am very interested in these yes, not in what's going on here. I would like to, but it's very complicated. So I will take that complication away for now. And especially when you start to couple social and ecological system, I think at the end of the day what is important is what decision has been made, and what are the conditions under which this decision has been made. So what drives the decision making, rather than what drives the individual cognitive process, because they're all very different. Or all very similar at the same time. and we can have, as we talked before very briefly about networks, we have information and knowledge diffusion. Oops. It can be modeled as a disease spreading, or as anything that spreads on a network can be modeled with some basics of epidemics. So an individual or an organization is infected when it receives information of knowledge. Now there are different ways. Sometimes we accept that knowledge and we never change it. It's not really appropriate, I think, for humans. And sometimes we accept the knowledge for a while and then we become susceptible to new knowledge or to new information. So, and once we have that knowledge and once we believe something, we might be able to propagate that belief, propagate that knowledge to other individuals. Is it clear? Yes? And the spread of infection or knowledge or information, a lot of time depends on the individual capacity to acquire and retransfer, special individuals and topology. Again, authority, personal views, personal characteristic or personal views, and networks. Now, basic epidemiology, we have three types of models: susceptible, infected, susceptible, infected, susceptible, and susceptible, infected, removed. Sorry. Okay. So, how would you describe susceptible and infective in an information and knowledge context? What does it mean? Having a model that is only an SI model. Yes, so basically this, in epidemiology, is like I'm susceptible to a disease. Once I'm infected, I stay infected for the rest of my life. Right? What does it mean in the context of knowledge and information?
Bias.
And I will never change my opinion. Once I have an opinion, I'm always infected with that opinion. Right?
So susceptibility can be zero if you don't want it, if you're not open to.
What? Yes. But once you're open, once you change your mind once, you keep it that way. You don't change it again.
Or you change it again if you're susceptible again.
Yes, but yes. If you're SIS, in an SIS context, you change it again. You become susceptible with another probability to another type of idea.
So the first two in a way are similar because if you're removed,
Yes. You're removed.
you can't infect someone else.
Exactly.
So you can't.
But most of the time we use only SI and SIS. We don't use the remove. The remove is used in epidemics. It means you die. Yes, we can die, but I like to think positively. I don't want to think about that yet. Way too young. For example, if maybe there's a numerical simulation on a network, here it is. We have a scale-free network and a randomized null network. Then we have different types of absorptive capacity, that is, how much we're able to understand and retransmit, in our power to retransmit that information. And we can see that if you go over time, this is the percentage of the population that has that same idea. We can have different curves according to topology. So according to the network shape and the absorptive capacity, we have a different type of diffusion. That is why it's so important, not only your personal characteristics, but it's very important to understand that we are in a context, we are in a group. And our groups are structured, so we don't interact. I don't interact with all of you at the same level. I have certain people I interact more and certain people I interact less. And that is very important to take into account. You see heterogeneity or the topology of contacts is very important, I do think. Okay? And I have a very brief example. There's another nice thing about NetFlow is that you can actually publish your models on the internet very easily. It's like an applet. Where is the applet? You can upload it. And there's like 3 different types of networks: K-free, random, and small volume. And I keep everything the same, and I look at the probability. And in theory, if you do it enough times, scale-free and small board networks are the fastest in spreading any kind of thing. And random networks like information, knowledge, diseases. While random networks are much slower in that sense. Okay? Yeah. So, this is, for example, you see you have 6, 16, 11. These are actually the times that until everybody heard the rumor or has that knowledge.